Decided images to the total energy used is significantly more in transport because the total energy efficiency from is from total energy. So the two states most need of this thing. Do you want to say anything? Of the state for it, with the DDP. DDP market value of all the various goods and services produced in the country water. Here, for only 1 year time, whatever services are provided, whatever the services are providing, All these services are provided for the production. Now we can see these are the contribution of it includes all in culture contracts, workshop, in all circumstances, manufacturing, which is services. So the total services, these kind of services basically needs manufacturing, manufacturing needs or the GDP increase of 20% statistics and second is also includes. Employee, you can see, yes, the financial condition include the energy requirements are is as people will about the power. So can say this we is going to you
Am I audible now properly? So anybody can respond if I am properly audible.
Sir, you are not audible.
Am I audible now? Am I audible now?
बहुत धीरे, वेरी स्लो, बहुत धीरे धीरे आवाज आ रही है.
Okay. अभी if it doesn't work, let me attach my earphones. Now, is it audible now, or do I need to switch to my earphones? Okay. Hello, am I audible? Hello. Is it clear or now? Okay, let me change my. Hello.
Sir, please continue your class.
Was audible to you now?
Yes, sir.
Was sorry for this disturbance. So there was some technical issues. So I am now
Okay, sir.
properly audible, right?
Yes, sir.
Okay. So sorry for that. So this question second was done. So we'll go for the third. So the third question says a hypothetical Dyson sphere will capture all of the energy from the sun coming to the orbit of the Earth. So basically, what is a Dyson sphere? So Dyson sphere, just imagine this is the sun, and do you want to capture all the solar energy emitted by the sun? So what will you do? You will try to cover the sun completely. So you can take either solar cells to this kind of structure. So Dyson sphere is basically a hypothetical mega structure. Like it is not in real, but you just imagine a structure which can cover whole the sun. So this kind of structure, and you try to cover all the sun. So all the energy emitted by a sun, it will be captured by our this structure. So this is basically called the Dyson sphere. So yes, the statement is true that this Dyson sphere will capture all the energy coming out of the sun. So this question is true. This statement is true. The fourth question. So it says there is a strong need to change the source of energy used by the world. So we can see from the energy consumption scenario also. So why we need to change the source of energy? So from this graph also, we can see the demand of energy and energy consumption is increasing day by day. So if we can the forecast the energy consumption, so it is going linearly very higher. And also we are mainly using all the conventional energy sources. So all the energy is generated by either by coal, by gases, and other conventional energy sources. So these are basically the major source of CO2 production. So we need to reduce the CO2. In this graph also you can see this global CO2 mean CO2 it is increasing year by year. So by the increase of year, this global emission of CO2 or the CO2 level in air, these are increasing. So we need to decrease or we need to just stop increasing the amount of CO2 release. So we need to go from the conventional to non-conventional or renewable energy source, renewable and clean energy source. So yes, there is a strong need. You need to move from the conventional to renewable and clean energy sources. So this was the question 4. The question 5 is the solar spectrum that reaches the surface of the Earth is impacted by gases in the atmosphere due to the wavelengths they absorb. So we need to find that either it is true or not. So this is the Earth's surface and this is the sun. So solar energy. So we know that solar energy there are many components. Some energy is reflected by the Earth's surface. So this energy is coming and reflecting by the Earth's surface. And some energy is absorbed by the Earth's surface. So if this is sun energy or the solar energy, some is reflected, some is absorbed, and also one of the main feature, because atmosphere, there is some this is atmosphere. So many gases are present like CH4, H2O. H2O is basically the water content, CO2. So these kind of gases are uh, present in the Earth's atmosphere. So these gases, the gases will interact with the sunlight. So the gases will basically, this is the sunlight. So the gases will interact and the gases will absorb the sunlight. Absorb the sunlight. So depending upon the wavelength, whatever and the type of gas, they will absorb the different wavelength of gases. Like CH4 will absorb some light, it will emit. Like similarly, the H2O will absorb sunlight, and then it will emit. So yes, we can say the solar spectrum of the Earth is impacted by the gases present in the atmosphere. Okay, so this was and the same thing. This is the main cause of the greenhouse effect. So the greenhouse effect is basically these kind of gases like methane, then CO2. They interact with the solar spectrum. They absorb some energy, and then after that they release the energy. So the greenhouse effect we will see in the upcoming question in details. So these were the previous one were the non-graded assignment problems. and these are the previous year questions. Your previous year assignment question with the or the quiz questions. So these are also important for your main exam. So the first question is: as the GDP of the nation increases, energy consumes generally. So in this previous question also, we relate the GDP with the power or the energy consumption. So we saw that there's a link between GDP and power consumption. As the GDP increases, the power consumption also increases. Here also, the curve says the same thing. The blue one is the GDP per capita. The blue one, this is GDP, and the red one is the energy demand or the energy consumption. So we can say that yes, this we can say the increases. Yes, the answer is increases. GDP increases with the GDP of the nation. Energy consumption generally increases. In the question two, there is an example like Maharashtra consumes more energy than Tamil Nadu. Basically, one is Maharashtra, one is Tamil Nadu. So, based on the trend using seen in the relationship between energy usage and economic activity in India, we need to check these two statements. So, first statement is Maharashtra has more GDP than Tamil Nadu. So, first statement is Maharashtra had more GDP as GDP for the state GDP. So, Maharashtra has higher than Tamil Nadu. The statement was Maharashtra consumes more energy. So, in the main statement was in terms of energy. So, Maharashtra consumes more energy than Tamil Nadu. So, first statement was in terms of GDP. Second is in terms of Tamil Nadu has more industrial output. Industrial output. So, it is saying that Tamil Nadu has more industrial output than Maharashtra. So, from our GDP to energy relation, we know that GDP is directly linked with energy. So from the statement one, we we can see that yes, if the energy consumed by Maharashtra is higher, so its GDP should be higher. But the first statement is correct. The second statement is saying the industrial if the industrial output of Tamil Nadu is higher, so the energy consumed by Tamil Nadu should also be higher. So this second statement is not correct because the industrial outputs comes in the GDP itself. If the industrial output is higher, so this energy consumption also should be higher. So our conclusion A follows. Conclusion A is correct. Also, this option first is correct. Also, this third option, conclusion A follows, but not the conclusion B. So both options are correct. We will see the answer. The answer is also conclusion A follows and conclusion A follows, but not the B. We come to this third question. So the third question says 40,000 years ago, atmospheric CO2 concentration was how much? And this is determined by using bubbles of the trapped ice. So this is a method to determine the CO2 concentration in the past. So basically what people have done from the earth, these are North Pole and this is South Pole. So people have chosen the areas which are not uh, influenced by human being, like Antarctica, and this is the northern places, like some places in Alaska. So if we want to know the CO2 level like says 40,000 years ago. So what we need to do, we'll need to find the ice which is 40,000 years old. So so people try to find the ice, and with the carbon dating they try to figure out the age of the ice. So with the 40,000 years ago ice, they found some air bubbles in the ice. So whatever the air is trapped, they took that sample, the air only, and they checked the CO2 level in that air. So they found that at very uh, at after around 40,000 years ago, the CO2 concentration was very low. It was around or less than 300 ppm. So in these three or four options, we can say the CO2 concentration level was not more than 300 ppm. So it was less than 300 ppm, and also the here it will be air. So the air trapped in the ice, it was taken, and the sample and the CO2 level in that CO2 concentration level in that air, it was estimated. So the option one is correct. 300 ppm in the air. Also, in between, if you have any queries in any questions, you can just directly unmute yourself and just directly interact with me. We'll try to interact and we'll try to solve your queries. Yes. So the fourth question or the next question, this is the glaciers are melting due to the increasing CO2 level, CO2 percentage in atmosphere. Okay. So the two conclusions are CO2 traps the energy which comes from the sun. And this conclusion B is more CO2 in atmosphere means more absorption energy. So this is basically the greenhouse effect. This is called the greenhouse effect. So in greenhouse effect, what happens? The solar radiations coming from the sun, they hit the Earth's surface, and after some of the part is absorbed, but some of the part is reflected from the Earth's surface. So this Earth's surface, uh, this part reflected, which part is reflected with? So there are some gases or molecules of gases in the atmosphere. So basically, these are CO2, carbon dioxide, nitrogen oxide, then SO2, then oxygen, some methane or CH4. So these gases interact with the sunlight. So they absorb first CO2. CO2 will first absorb the light, then it will emit the light. So what will happen? It will absorb and it will emit and reflect back the light to the sun, to the surface of Earth. So with this reflection back, the temperature of Earth's surface increases. Similar example we see with the greenhouse effect farming. So what people do, they will just like like places where temperatures are quite low, so they will just make a shade, or they will just cover the surface with a transparent, this is kind of transparent film. It can be made up of like plastics. So this is transparent film. So in the day, the sunlight will penetrate and under the penetrate through this transparent film, and they will just heat up the area, this volume, this area, it will heat up. And when it reflect back, so this transparent film will not allow it to the sun rays to get out of the out of this chamber. So it will again reflect back the sun rays for this solar energy inside this chamber. So ultimately, by using this transparent film, the temperature of this volume of- will increase. And the same thing happens with the Earth's atmosphere. So here we can see here, yes, conclusion A is right. CO2 traps the energy which comes from the sun. And more CO2 means more absorption and more reflection to the more uh, more energy will be reflected towards the earth sun, toward the earth, so temperature will increase more. So if the CO2 is more in amount, the temperature will be higher. You can see in this picture. So this is the normal greenhouse effect, and this is human enhanced, because due to the human activities level of CO2 has increased. So we can see the temperature is increasing day by day. That is the main cause of global warming. Those CFC gases and CO2 emitted by humans. So it is increasing the temperature. So we see the global warming and the changes in climate in the current days. So yes, the option B is also right. The conclusion A is correct, right? And conclusion B is. So so we'll see in this simple manner. So the question is asked the what's total energy uses in the same is the same as the energy received by Earth from Sun is how much time? So they are basically world's total energy uses. So we need to like we need to know from the previous lecture also we know that humankind uses 500 exajoules of energy per year. So we need to find out that how much time it will take the energy received by Earth from the sun, how much time it will take to receive this much of energy, the 500 exajoules of energy. So we need to just have some calculations. So first, total energy emitted by the sun we have also seen earlier. It is 384 watts or 3.8 into the power 16 watt. So, but it is the total energy emitted. Then we have to go. We have to see that how much energy is received by Earth. So these are the factors we need to consider, like how much far the Earth is from the sun. So radius of Earth's orbit we need to consider. Then power of the sun is the 84 watts. So sun's radius and Earth's radius. We need to consider all this parameter. Then we will get the intensity of sun's radiation at Earth orbit. So basically, this is the power emitted by sun total power. Then 4 pi r square. This is basically the area of the Earth's surface. Radius is 6,371 kilometers. So this is total area of Earth's surface. So if you divide the power with the area, we'll get the intensity. So intensity is basically in watt per meter square. So this we get 1377 watt per meter square intensity. And so this is the intensity of sun's radiation. Now we have to see that how much intensity or how much power we can absorb. So if the sun is there, so assume a disk. This is a disk. So only uh, uh, for an estimation, the area of the disk is the area where the solar radiation is incident. So the area, this much area, this will absorb the sunlight. So we need to figure out how much area is this. So basically the area is pi r square. So r is the radius of Earth. So pi r square. So it will be 1.27 in 10 to the power 14 meters square. So this is the area and this is the intensity. So basically multiplying the area with intensity. So this is the total power received by Earth from the sun. So this is 1.755 into the power 17 watt or in joule per second. So this is the power received well calculated. So this is per second. So if you need to convert it in total power in each year. So basically this is joule per second. Then we will multiply with 60 to make it minute. Then it will be multiplied by 60 again to make it an hour. Then 24 hour in a day. So it will be multiplied by 24 to convert it in days. Then multiply by 365 to convert it in year. So this is basically 5.5 into 10 to the power 24 joules. So this is the energy received in a year by Earth from the sun, or you can say it 5.5 million exajoules. So now we need to compare that 500 exajoules is the energy required or energy consumed by the humankind, and 5.5 exajoules, million exajoules, or 5.5 into 10 to the power 6 exajoules. This is Earth received from the sun. So we will just divide it and we will get this or 0.033 days or 0.79 hours. So we need 0.79 hours total, but we know that total energy is not uh, uh, absorbed by the, or the total energy received by from the sun is not absorbed. So on 30% of the energy is reflect back from the Earth's surface. So only 70% is can be utilized. So we will factor out this 0.70. So it will be around 1 hour. So it is 1 hour, or 1 hour is also, if you in days, if you want to calculate, so 1 by 24, it is around 0.042 days. So the first answer is second is correct and the fourth one is correct. Okay. So the next is a relatively easy question. Again, what are the various options possible to maximize energy received by planet from its star? So for example, this is, let's say, sun. This is, otherwise let's take it as Earth, because sun is larger than Earth. This is emitting solar power, solar insolation or solar radiation. Please don't use that feature. This sharing option, somebody mistakenly just shared their screen. I'm sharing my screen again. Okay. So the first option, increasing the surface area export of the planet. So yes, the total surface area, if we increase the surface area, the maximum energy will be increased. We have seen in the previous question also, more the area, if we increase the surface area of the planet, the energy received will be increased. So yes, correct. The first one is correct. And bringing the planet closer to the star. So this distance, if we bring the Earth closer to Sun, the total energy received will be higher. So it is also correct. This is correct because the suns emit the power radially. So it is emitted in all the direction. So if the Earth is closer to Sun, the energy received will be higher. And if it is farther, the energy received will be lower. And also using the Dyson sphere method, so we can maximize by using the Dyson method. Dyson method we have already discussed. So that was the method to use used to collect all the solar energy of any planet. Moving the planet further from the star. So this one is the opposite. If we put the planet further, it will decrease the energy received. So this one is incorrect. So we can check if the first one is correct, the second one is correct, and the third one is correct. Okay. So the temperature of sun surface is approximately how much? Again, in the first question, I guess we discussed this, how the sun surface, how the sun emits energy. So basically it was due to the fusion. So 1H2 and 1S3, they made the helium or the alpha particle plus one neutron plus energy. So basically this energy we receives in form of solar energy. So this energy, so due to this reaction, this is extremely exothermic. So the temperature goes around 5,000 degrees Celsius. So here this 5,500 degrees Celsius is correct. And the second option is the similar in the order of magnitude to the temperature attained during the arc welding. So arc welding, all of us have seen. This is arc welding. So arc welding is used to join two metal parts, and the thermal profile. So thermal profile is shown in the right side. So this is basically the temperatures at the maximum at the center of the welding. They goes around 1500 to 1600 Kelvin. So again, if we change it in Celsius, these are again around 1500 degrees Celsius, or in the magnitude of 1000. So this option asks magnitude of the temperature. So magnitude of temperature means if this the sun's sun if the temperature of sun's surface is 5,500 degrees Celsius, so it is around 5,000, and our is also around 1,500, so it is also in the 10 to the power 3 range, and this is also in the 10 to the power 3 range. So you see 1.5 in 10 to the power 3, and it is 10 to the power 3 times 5.5. So basically the magnitude is similar. So the option is correct. Like the order of magnitude is similar for both the arc welding and the sun's surface. The next question is, arrange the following in their increasing order. So three options are given: radius of Earth, radius of Earth, radius of Sun, and radius of Earth orbit. This is basically very known and very easy to understand. So this is the radius of Earth, and this is the radius of Sun. So everyone knows that Sun is larger than Earth. So this is larger. This is 0.7 million kilometer, and this is around 6,000 kilometers. And the radius of orbit. This is the radius of orbit, the distance between Sun and Earth. So this is basically the largest. So our options are, which is the option? The orbit, radius of Earth's orbit, then the radius of Sun, and then the radius of Earth. So option A is correct. Again, we can confirm that yes, option A is correct. Okay, so next question is, at any given point of time, okay, one side of Earth radiates energy obtained from the Sun back to the space. Okay, so these are two sides. This is another side. So at one side, when the light rays are coming, so here it is day, and the opposite side it is night. So our statements, what are the statements? Earth radiates energy from this obtained from the Sun because it is night on this side, on that side of Earth. So yes, it is night here. So temperature of that side of the Earth is more than the temperature of dark side of the space. So if we consider this as space, so we know space the temperatures are very low because there is no quantity in space. So this is only vacuum, and because Earth has some temperature, some finite temperature due to this surge light rays. So Earth gets some temperature higher. So this temperature is always greater than the temperature of Earth. This vacuum temperature. So we can say yes. Second option is correct. And the sun it so when the temperature is higher, it will emit some radiation to space, and it will cool down. The third option is the surface temperature of star is less than the of that of the sun. So yes, that is correct, but it is not the reason why the earth cool down. So if this is the temperature of that side, if we can say this is the Tn, and this is the temperature of sun. So these are not correlated directly. So this statement will not be correct. And the fourth option, the moon is hotter than sun, so the moon has no role. So it is also incorrect. So we can check that first option is correct and the second option. If anyone has any doubt or anyone didn't understand the any point, I can repeat. So you can just let me know.
Yes, sir.
This 10th question is the intensity of sunlight incident on the Earth is higher during the uh, space than space of the day, and therefore a solar device captures more or less light during the part of the day. So we know that it is easy to understand that intensity. This is sunlight. Sunlight intensity is high in middle of the day and low in morning or evening. So higher in the middle than morning. So middle morning. So this is correct. And therefore a solar device captures more light during the part of the day. So during the middle of the day. So the option one is correct. So that is why usually all solar photovoltaics or all solar panels they produce more power in the middle of the day compared to morning or evening. So similarly, for we chose the first option, the middle morning more. It goes similarly with the middle evening more. The fourth option is also correct. So these were the previous year's questions or the non-graded assignments. So now we are looking for the previous quiz questions. So these are basically the week two quiz questions. So because these were graded or your response were evaluated, so that is why we didn't discuss it earlier. So now the deadline of this submission of these questions has over. So now we are discussing these questions. So if you have any doubts in this question, we can clear it out here. And we have still 1 hour to go. So we will take this question easily and slowly. If you have any question, you can just stop me in between and you can just ask me anything.
No doubt, sir.
Okay. Now this question is the GDP of a nation is $1 trillion in 2015 and it increases to $2 trillion in 2020. So in 5 year time, the GDP got doubled. So which of the following is most likely to be true as it moves from 2015 to 2020? So we already discussed what is GDP. So again, the GDP is the gross domestic product. Yes, we can write it here. This is the gross domestic product. So this is the whatever the production was in. So it is basically considered in a year. So in a year, whatever the production was of a country, or uh, I can write here production plus services. So whatever the services are provided within the country, so these whole are considered in the GDP. So this GDP, so if you see the contribution, so all manufacturing, all services, all transport, construction, agriculture, electric, gas, whatever you see in your surroundings, it comes into inside into the contribution of GDP. So the option 1 says oil consumption decreases in the nation, but if its GDP is increasing. So here from the statement it shows that GDP is increasing. The oil consumption decreases in the nation, but it is not the possible, because if the GDP is increasing, the consumption of energy increases, because we know there is a link between GDPs and energy consumption. So this energy is also from the oil. So in this example of oil consumption of for it is for for India. So we see that as our GDP is increasing, the oil consumption is also increasing. So this is not the correct. Oil consumption increases in the nation. The second option is energy consumption of the nation increased. So yes, because we already understood this link between GDP and energy consumption. So this second option is correct. Life expectancy in the nation decreases. So if the GDP is higher, it has the impact. It has also the impact on life expectancy. So because if GDP is higher, all the health services provided will be higher. So you will see good expectancy of life in a comparing if a rich country versus a poor country. So all the developed or rich countries, they have higher life expectancy. So this statement will be incorrect. So it should be increased instead of this decrement. And the fourth option is the goods and services totaling to greater value are being produced in the nation. Goods and services totaling to greater. So yes, correct. Because so all the goods and services, this gross domestic product, they will be greater value. If the GDP increases, these goods and service totals will also be increased. If we check, energy consumption of the nation increased, so second is correct, and the fourth one is correct. The next question is, you can read this question once. The question says, which combination of energy resources is more useful to us for a long-term uses? If we see these combinations, first is conventional energy plus inexpensive coal. So coal is, for a long term, coal is not a sustainable alternative of energy. So we need to avoid all the conventional energy sources. Conventional sources. So conventional sources are basically coal, oil, all petroleum. So we cannot rely on coal, as well as we cannot rely on the oil, cheap oil. Because cheap means it will be financially easy, but for the long term uses, we need to reduce the CO2 levels. So we need to go towards renewable energy sources. So we need to go towards renewable, which plus which are clean, and non-conventional, which are clean. So renewables are, again, these were conventional. So we need to go towards non-conventional. So the both second and third options are correct. So we can check these options are correct. So the option, this question 5 is wind and solar energy are. So we need to see the options. Renewable energy source resources. So this is very known to us now that these are renewable energy sources. So option A is correct. The second option is very clean form of energy in comparison to all other energy available resources. So yes, wind and solar, these are the main renewable energy sources. These are the main resources in the renewable energy sources. So option A is correct. Option the second is correct. Intermittent in nature. So we need to see what is the intermittency. So intermittent in nature, you can understand by reading this. The energy that is not continuously available. And also, we cannot rely upon the supply, upon that energy for a stable supply. So if you rely on the solar, so let's say if you don't have any energy storage system, you don't have any battery pack installed with the solar panels. So in the daylight, in the daytime, you will the solar panels will produce a lot of energy. So you will have enough energy in the daytime. So all your applications, electronics, they will run on the solar power. But in the night time, in the night time, the solar power will not, because sun will not available in the night time. So the solar panels will not produce any power. So this kind of nature, which is not continuously available, so power is not continuously available. So that is called intermittency. Similarly, for the wind, if you see, if one day is very windy or the winds are very high, so the power generated by windmills will be quite higher. But if the another day the wind currents are quite low, then the power generated by the windmills will be lower. So that is not the power is not available continuously. So that is called the intermittency or the intermittent nature of energy sources. So we cannot rely upon the on the this intermittent energy sources without proper energy storage. So we need energy storage. So whenever we have the energy, we have the power, we have the electricity, we will store the energy in this energy storage. So if we have a solar panel, so this is your solar panels. So it will be integrated with the battery pack. So whenever in the sun in the daytime, we will directly get electricity or the power from the solar panel, and it will also charge the battery pack. But in the night time, when this so in the night panels are not producing any energy, we can rely on the batteries. So to overcome this intermittent nature, we need this energy storage system. So this is called intermittent nature. So wind and solar both are intermittent in nature. So fourth option is wind and solar energies are of the same value at the same time of each day at a given location. So that is not correct. because they are not in the same value. If the sunlight is high, they will see high values. If the sunlight is low, it will have the lower values. Same with the location. If some locations see winds are very high, so we'll see the high power generation. And if the winds are low, we will see the low power generation. So our three options are correct. Option fourth is incorrect. So the question six is electrochemical devices can be used to store. So first we need to see what is electrochemical devices. So you can, if you divide these two terms, electro is basically on the electricity plus chemical devices, मतलब the chemical reactions. So the electric energy or electricity plus the chemical reactions. So the electrochemical devices, what they do, they generates the electricity from chemical reaction. So if they have some chemical reaction, so they will generate some electricity. Yeah. And similarly, if you have electricity or electrical energy, so they will cause a chemical reaction. So from the chemical reactions, you will get electrical energy. And from the electrical energy, you will get chemical reaction. So these are basically, if you see batteries are same. If you charge them, they will store the charge in some chemical reactions. And whenever you require from the chemical reactions, you will get the electrical energy again. So batteries, fuel cells, like hydrogen fuel cells in supercapacitors, so they all do the same thing. So what we can store in these devices? So wind energy. So wind energy we can store, like from the windmills we get from the wind energy we get electrical energy, and we can store in batteries. Similarly, solar energy. From the solar panels we can store in the batteries. The fourth option is the mechanical energy as chemical energy. So mechanical energy, if we convert in the chemical energy, we can also store in the batteries. But heat energy directly as heat. So none of this technology, they cannot store heat. They only store electrical energy. So this third option is incorrect. So we cannot use to store heat. Option first, second, and third is the fourth is correct. So you can see the wind energy is correct, solar energy is correct, and the fourth one is correct. Second question is, which sector shows the largest energy consumption pattern? Residential, transport, industry. So by the by your surroundings also you can understand, and from this global energy demand by sector, this data from 2016, you can also understand the most of the energy consumption is in this industrial sector. So the industrial sector, whatever the manufacturing and whatever the industry related works are going on, these are under this industrial sector. And commercial and residential, these are after the industrial. So the largest energy consumption is shown by industry. And again, the industries, they cause most of the energy consumption. We have a good discussion on industry in this 10th question, so we will come later on. So now we will discuss this question 8. So India and China have, we need to see what are the options. More renewable energy sources than other countries, more scope for the automobiles industry to grow, lower GDP than most countries, and lowest energy uses in the transportation compared to other countries. So the first option is more renewable energy resources than other countries. So this statement cannot be true because renewable energy sources are basically sun, wind, some geothermal. So these are renewable. These are almost distributed evenly or uniformly to all countries. So China or India, they do not have the higher renewable energy sources. So this cannot be correct. All the countries have almost similar resources. We will see the second option, more scope for the automobile industries to grow. So the automotive industry, this is basically linked to the population of a country. So more people in a country will have more number of automobiles. And now we see that number of vehicles owned by a person is increasing in India also. So people are getting enough financially stable. So the number of automobiles like vehicles like car, bikes, they are increasing. So the population is one factor, and the financial stability, which is linked to GDP, that is one factor. So especially in India and China, where the population is very high, so the automobile sector or the automotive sector, these are increasing rapidly. So we have more scope of automobile industry to go. So the second option is correct. The third option is lower GDP than most countries, but as we know, India and China, these are very much faster growing countries. So their GDP is also very high. So this is incorrect. So the fourth option, lowest energy users in transportation compared to other countries. It is also incorrect because they do not have the lowest energy users. Because also in India and China, these are large countries geologically. So we have a good chunk of energy users in transportation. So the option second is correct one. Yes, one more interesting question is the cleanliness which with which fuel is burned inside an auto engine is decided by what? So basically, we need to see internal combustion, complete combustion, or it is called the IC. It is the internal combustion in an engine. So in an internal combustion, what happens? We have one sources. So this is fuel. Fuel is basically hydrocarbons. So if we see like we usually use petrol and diesel, these are fuel. So all fuels are basically the petroleum products. So these are hydrocarbons. So in an engine, what happens? The hydrocarbon, like for here, we have an example of CH4. This is methane. So this is a methane gas. So they interact with oxygen. So oxygen is present in air. So we see one molecule of CH4, one molecule, and one molecule of oxygen, O2. So they interact in a combustion engine. So at a high pressure, compression give high pressure, and there is a spark. So with a spark, they get ignited. So it will interact and it will give us a product of CO2 and water, H2, and lot of energy. So either in terms of heat Do we see in terms of heat, or we see this energy release? So this energy used to drive the automobiles. Whatever we see in real life, the car or the bikes or whatever, wherever the engines are, be it be petrol, be it be CNG, be it be diesel, so they all work in the same phenomena. So one the fuel is mixed with air, they get ignited, and after the ignition, we will get a product of CO2 and H2O. So all this, if you see one molecule of CH4, one molecule of oxygen, they will interact and they will give you CO2, one molecule of CO2 plus one molecule of H2O. So the ratio of hydrocarbon versus oxygen is 1 to 1 raised to 1. So this is a very clean ratio. So if the ratio is 1 raised to 1, we will get water and CO2 with 1 raised to 1. If fuel is higher, we will see more fuel in the exhaust. So fuel would be added with our product. Similarly, if air is higher, then it will be less efficient. So here I can write. So if the fuel is higher, it will be not clean. And if air is higher, it will be not efficient. Because you need enough air. If air is higher, then fuel will be less. If fuel is less, then air will be higher. So basically, we need a 1-to-1 ratio. So fuel to air ratio we need to maintain for a proper clean combustion, and which is very efficient and which do not leave any fuel behind the exhaust gases. So we can see this example in real life also. If our engines are properly tuned, so we'll see the exhaust fumes will be very clean. If it is not tuned, if air is higher or if fuel is higher, so the mixture will not be proper, and we will see the exhaust will be darker in color. So basically, this is unburned fuel. So unburned fuel, they will show as a black or dark fumes. So this is the question 9. Fuel and air, the correct. Yes. So again, the one question on the industrial sector. So industrial sector use maximum energy for which of the four options? Generating electricity, air conditioning, processing heat, and the lightning. So basically, this I will tell you the answer. This is the process heating. So process heating basically it is very important in the industrial sector. It is why it is important. So we'll see what is firstly process heating. So process heating, whichever the process includes heating of water or any other media, like if you are creating steam or warm water, hot water, so if you are heating anything, it comes in the process heating. So basically these are done with this conventional energy source like natural gases, coal, petroleum products. So in industry, so we can see it is important because industry of the total industrial energy demand, process heating is 1920 terawatts, or around 60% of total energy consumption. So we can see the process heating itself is 60% of total energy consumed. So that is why this is 60%. This is a very high contribution of energy. So that is why we need to consider the process heating. So this is an example. This is the example of process-wise heat demand and share of energy consumption in the dairy industry. So in case of India, so in dairy you will see these are the processes. So there are various processes like cooling, cleaning, pasteurization, sterilization, chemical processes, evaporation, spray drying. So you will see most of the process are uh, most of the process are going on the temperatures higher than the room temperature. So if we take 20 or 27 as a room temperature, so most of the process are going at high temperatures. Only few process are at normal room temperatures. So this high temperature, they need high energy. So that is why you need to consider the process heating. So the industrial sector uses maximum energy for process heating. So basically, this is the question. This was the last question for previous year questions. So here, all my questions are done. So this is basically the week 3. So if you have any doubts, I am here. If you want to interact about anything, you can ask me. Or you have any doubt regarding the course, regarding the questions we discussed, or the course taught uh, in the main lectures. So you can let me know. Also, I am here. This lecture will go up to 9. So I am here for 30 minutes. So we can discuss about anything, this course or any other topics related to this course, we can discuss.
Yes, sir.
Otherwise, you can just unmute yourself. You can just interact with, we can just interact. You can just tell uh, which kind of education you are undergoing. You can just discuss about yourself if anybody likes to interrupt. So we had so basically we have this week's ungraded questions, last year's quiz questions, or these were the graded one for the last year, and last week's questions. So if you have any doubt, you can let me know.
No doubt, sir.
Okay. You can also interact. You can just tell us what you are doing in education and why you have chosen this course. Is this course is helpful for you? You can just interact for about anything if you like to.
Myself, Said Khan from Master Nanded. I am studying BTech Mechanical Engineering from MGM College of Nanded.
Okay. Okay, good. So is this course going well? Is this helpful for you?
Yes, sir. Yes.
Okay. So you are doing any specialization in MTech in these any specific projects or anything like that?
Sir, I am not doing project. I am doing internship.
Internship where?
Yes.
So I will be here for half an hour till 9. If you have any doubts, you can let me know. Otherwise,
No
you
doubt,
can
sir.
just.
No doubt, sir. Sir, lecture is continue or not?
Sorry.
Lecture is continue or not, sir?
Lecture is done. If you have any queries, if anyone have any questions, they can ask. I am here till 9. So if you don't have,
Okay.
you can just yep.
Okay, sir. I leave.
Sure.
So I can leave, sir. Meeting.
Yes, yes, you can leave. If you
Thank
don't
you.
have any question, you can leave.
No, sir.
Okay.
Thank you.
Okay, so now today we will wrap up this session. So we will meet again in next week and we will discuss this week 4 of the non-conventional energy sources. So the next lab session will be on the same time at 7 p.m. on Monday next week. Okay, thank you all.